Hello and welcome to my all of iGCSE 0580 paper 4 video. So I'm going to go through my top 10 topics that appear the most often on the paper 4 and then make sure to go through a few questions to make sure we're happy with those particular topics. Right, let's get started. Make sure you have your formula list handy. We are going to refer to that as we go along. So this is pretty tricky. So the length of the arc AB, so this arc here is equal to 4 pi over 3, and the area of the sector is equal to k pi. We're not told what the angle is, but we'll just give that a letter, call it x. And we want to find the value of k, so essentially the area of the sector. Now to do this kind of question, we need to know what the circumference of a circle is, so that's equal to 2 pi r, and the area of a circle is equal to pi r squared. Because we need those basic formulae to work with the area of a sector and the circumference of a sector. Now let's do the area first of all. So the area of this is equal to the angle, which is x, divided by the total turn, so that's 360, multiplied by pi r squared. Now remember, our radius here is equal to 8, so it'll be pi times 8 squared. And we're told that that is equal to some constant k, which we're going to find, times pi. Now the arc length, let's just write a formula for this now. Well, that's equal to the angle again, divided by 360, so that's in common, multiplied by 2 pi r, so 2 times pi times 8. And we're told in the question that is equal to 4 pi over 3. Okay, so let's simplify these formulae down slightly here. So what we can do is just combine this together. So I'm going to put the pi next to the x here. You'll see why a bit later on. So we're going to get pi x over 360 times 8 squared, which is equal to 64. And if we do a similar tidying up procedure here, I'm going to bring the pi next to the x. I'm perfectly allowed to do this. So pi x over 360 multiplied by 8 times 2, which is equal to 16. And I'm going to do a very nice trick here. So I'm going to look at this part that I've just written out. And what I'm going to do is divide one equation by the other. Okay, now normally simultaneous equations you're adding or subtracting. Here I'm going to divide. So I'm going to take the first one and I'm going to divide by the second one. And you're going to see a lot of things disappear and actually leave us with something that we can actually work out. So if I divide the top equation by the bottom equation, well, k pi divided by 4 pi over 3, so I'm going to write it as a fraction. Well, that's equal to pi x over 360 times 64. So I'm going to write this essentially as a huge fraction. But you'll see lots of things simplify. Divided by pi x over 360 times 16. Now this looks kind of horrendous at this point. It's like you haven't made this actually any easier. But actually we have. First of all, pi's top and bottom cancel. So that's helpful. First of all, this entire expression here cancels. So we have it top and bottom, so that cancels. And then we've just got 64 divided by 16. So how many 16s go into 64? Well, that's 4. How many 16s go into 16? That's equal to 1. And from this horrible equation, we actually get something very nice. So we get k over 4/3 is equal to 4. Just like that. Now remember, if you're dividing, so let's just remind you here, k divided by 4/3, that's the same as saying k times 3/4. Remember, keep it, switch it, flip it, and that gives me just 3/4 k. So this equation then just becomes 3/4 k is equal to 4. It's almost like magic, isn't it? Just seeing everything disappear. And then what's the opposite of timesing by 3/4? Well, we're going to divide by 3/4 on both sides. And if we do that, we then get, remember, using the same trick that we did before, so 4 times 4 over 3, which gives us our final answer of 16 over 3, which is also fully simplified compared to the answer you're going to see on the next slide as well. So you can check the answer. They've taken 64 over 12. Notice this is the same. If we divide top and bottom by 4, we get 16 over 3. So it is the same answer. I kind of like this solution. I was looking through a couple of different possibilities here, and I think actually that's quite a clean way of getting to the answer. Even at the beginning it does seem kind of confusing, but one of the great things at this point here is that everything simplifies and you're left with a really easy expression to work with. Right, let's move on to another reasonably tricky question here. So the sector and the circle have the same area. That's really important, so we'll come back to that. And the angle of the sector is 60, we're given that. The radius is 12, also given that in the problem. And the radius of the circle here is r. Work out the value of r and give your answers as surd, so keep that in mind, in simplest form. There's going to be some simplifying surds, which is also an important skill to know. Right, so let's just work out the area of the sector first of all. So area of sector, using the information that we have, well, that's going to be equal to the angle, so 60, divided by 360, multiplied by pi times the radius squared, so that's 12 squared. And then the area of the circle, which is the formula I gave you on the previous question, well, that's equal to just pi r squared. That's just our standard formula. And now we're told that these two are equal to each other. Therefore, 60 over 360, that simplifies to a sixth. So I'm going to try and do a bit of simplifying as we go. Times pi times 144. 12 times 12 is 144. Is equal to pi r squared. And at this point, I look for opportunities to simplify. So we've got a pi on both sides, so we can cancel that. We'll need to do 144 divided by 6. Let me just leave that there as a fraction to start with. Is equal to r squared. Now this is where we can use the bus stop method. I know everyone loves it at home. So how many 6's go into 1, 0? How many 6's go into 14? Or 2? And remainder 2. How many 6's go into 24? That's 24. And it should be a number that's essentially a whole number, generally on these kind of questions. Now at this point we want to get r on its own. So what's the opposite of squaring? Well, we want to square root on both sides of the equation. So we get r is equal to the square root of 24. And now we go back to our underlined parts. Remember, we want our surd in its simplest form. So it's got our 2 marks so far, but not 3 of them. So remember, to simplify surds, we're looking for the highest square number that fits in. So if I write down some of the square numbers here, 25 doesn't fit in, 16 doesn't fit in, 9 doesn't fit in, but 4 does. So we can break this down into 4 times 6. Notice 12 times 2 doesn't work because neither of them are square numbers. Then we can separate out the surds. And then finally we can write our final answer. So the square root of 4 is equal to 2. And then we get our very final answer of 2 root 6. Now some of these mensuration questions often end up on the most difficult part of the course, and they often integrate other skills into the question. Your equation solving, and in this case, simplifying surds as well. Right, so you can have a quick look at the solution there, and let's move on to the next one. So we want to find the volume of a cone with radius 3 and perpendicular height 8 centimeters. Give your answers in terms of pi, which is kind of a classic question. Now, if you don't know the volume of a cone, that is not a problem. Let's go all the way back because we have that formula. Volume of cone, and we're given that as V equals 1/3 pi r squared h. So first of all, I'm going to show the examiner I've actually read the formula sheet and write that in there. And now let's just substitute in what we know. So 1/3 stays the same. Pi stays the same. R squared, well, radius is 3, so you get 3 squared. And then the perpendicular height, that's important for a cone, that's going to be equal to 8. And then let's just sort this out. So 1/3 times pi times 3 squared is 9. And then 8, like so. And if we simplify this down further, 9 times 8 is 72. Let's bring that to the front. I love multiplying, you can move stuff around. And then we need to do 72 divided by 3 again. If you're not happy with that, you can use the bus stop. 3's into 7 go 2, remainder 1. 3's into 12 go 4. So then we get our final answer of 24 pi. Remember, wanted the answer in terms of pi. You're not expected to put this into a calculator or anything like that and then work this out. This is purely just writing it in terms of that particular number pi. Question 9 is here, and we have a sector of a circle which is given for us. We're told the radius is 8 and the sector angle is 165 degrees. And generally a paper 4 question, they will start off with some of the slightly easier questions here. And the first thing to do is work out the total perimeter of the sector. Now, what does the perimeter mean here? Well, we need to work out this arc length here. So remember, this is called an arc. But remember, we want the perimeter, and the perimeter is the distance around the entire shape. So once we've worked that out, we need to add in this 8 centimeters, and remember, this is also 8 centimeters as well. This is also a radius. So how do we do this? Well, to work out the arc, we need to remember this formula. It is not given to you on the formula sheet. So we have the angle, so 165. All divided by a total turn, so that's 360. And then we use the normal formula for the circumference of a circle. So remember, the circumference of a circle is equal to 2 pi r. Again, another formula you need to know. So if we use the formula here, so we've got times 2 times pi, and remember the radius is 8. So that's going to give us our arc. To work out the total perimeter, we're going to take what we've done for the arc. Again, notice I'm leaving the calculating until right at the end here. And then we need to add in the 2 radii. So we've got 8 and 8. So we add in the 16. And that's going to give us our final answer. So let's go over to the calculator and work it out. Okay, so I'm going to use this calculator here. Again, this is generally for the 0607 course, but I'm just using the standard functions. So we're going to type everything in here. So 165 divided by 360 times 2 times pi times 8. Now remember, that is going to give us the arc length, but then we want to add in the 2 radii. So 8 plus 8 is 16. And notice I've left all of this until the very last moment. Now I put this on a float 4. That'll give us enough here in order to get to the right answer. So we get 39.04, which I'm going to write in here. So 39.04. Again, generally I'm going to do this to 1 decimal place here, so this will be 39.0 for our 3 marks. So starting off kind of nicely, it does get harder towards the end of the question. Now part B is the surface area of a sphere, so underlining the key information here, is the same as the area of the sector. Now notice this is the area of the sector, not the perimeter anymore, and we need to work out the radius of the sphere. So we're given the formula, so that's very, very useful. It says A equals 4 pi r squared. Before we really get started, we want to work out the formula for the area of a sector. Now the area of a sector works a very similar way to the arc. So we take our angle, so we have 165 over 360, but this time we're going to times by the area of the circle formula, and that's equal to pi r squared. So in this case, it's going to be pi times, now our radius here is 8, so that's going to be 8 squared. And we're told that these two things are the same. So in this case, what we've just worked out, so 165 over 360 times pi. Now, as I go along, I do like to simplify. 8 squared here is 64. And that's equal to this formula here for the surface area of a sphere. So that's going to be 4 pi r squared. Now, one of the reasons to write this out so formally is that we can actually do some very nice cancellation. So first of all, we have a pi on both sides, so I can cancel the pi. Notice we've got factors of 4 on both sides. So how many 4s go into 4? Well, just 1. How many 4s go into 64? Well, that's 16. Again, 16 times 4 is 64. And notice by doing this process, I'm really simplifying this down very quickly. So we get 165 over 360 multiplied by 16. And now all I'm left with on the right-hand side, which is fantastic, is r squared. And so to work out the radius here, what's the opposite of squaring? Well, that's going to be square rooting on both sides. So I just square root the left-hand side, and that's going to be equal to, well, these two things cancel, opposite operations, equal to r. So notice I haven't reached for my calculator any parts in that calculation, and I always try and leave it until the end. That's a really cool tip for these AA star style questions. So let's go to the calculator and see what it is. So we're going to have a square root, and we've got a fraction here. 125. I mean, you could do some simplifying to make this easier to type into your calculator. And then we're going to multiply that by 16. Press enter. And then we get our answer of 2.708. So let's write that down. 2.708. And generally, I'm going to be rounding here to 1 or 2 decimal places. In this case, I'll round to 2.71 centimeters for our 4 marks here. So far, so reasonably normal. This is maybe a little bit trickier with the algebra. Notice part C here is when it gets quite difficult. Okay, and on to question C, which is where it gets slightly trickier. So we're going to take that sector that we've seen before, and we're going to make a cone from it by joining OA to OB. So let's identify exactly the comparisons between the sector and the cone that we have in front of us. Well, the first thing to consider here, if I do this in blue, is that this side here, the OA side, so again, you can always use these to help you visualize. That's going to be the radius, which was 8 from the sector. Again, I'm just using that directly from the letters here, O and A. And more importantly for the question in front of us, let's do this in green. So what we're going to do now is that the circumference, so this green part of the cone, that's going to correspond to the arc of the sector, which we actually worked out in the very first part of the question. So let's then do these two parts of the question. So first of all, we want to work out the radius of this cone. Well, remember the circumference of a circle, that's going to be equal to 2 pi r, and that's going to be equal to the sector that we looked at before. So remember, we had 165 over 360 times 2 times pi times 8. So that came from part A of the question. Now we can do lots of cancelling here, which is amazing. So we can cancel out the pi's from both sides. We can also cancel the 2's from both sides. And then r then just drops out to be 165 over 360 times 8. Now again, you could do this without a calculator, but let's go to my calculator and work this out. So all we do is just type in 165 over 360 times 8, giving us the exact answer of 11 over 3, but can be written as a decimal as 3.67. So we're going to pop that across. See, this 11 over 3 is going to be important a little bit later on, but for this question, we're going to write this to 2 decimal places, so 3.67, like so. And on to part D, where we need to find the volume of the cone. And usual with these 0580 question here, they give you the formula you need to use. Now, if we look at the formula, the thing that we're missing here, the thing that we don't know, is the height. Once we know that, because we have the radius, remember the radius is what we just worked out as 11 over 3, then we can just plug it into the formula. Now notice here we have a right angled triangle. So if I just draw this out separately, so we can really see what's going on, our radius, which is the one at the bottom here, is equal to 11 over 3. We know the length of the radius, this was 8 from the sector in part A, so this is equal to 8. and this is h here, which we don't know. Now again, we can use Pythagoras for this. Again, for the more advanced skills, so looking at the A grades, for example, I highly recommend you get in the habit, when you use Pythagoras, of just write it in one clean calculation. So h is equal to 8 squared, remember this is the hypotenuse here, minus the smaller side squared, so 11 over 3 squared. Now notice I'm not rushing to my calculator here to actually work this out as a decimal, because I'm going to need it in the last calculation I've underlined here, but I've shown my working to guarantee 2 of the method marks. Now to work out the volume, all I'm going to do is substitute in everything that we have. So we have 1/3 times pi. Now the radius of this particular cone we already worked out, so 11 over 3. And then the height, which we've just worked out as an expression here, so 8 squared minus 11 over 3 squared. So notice I haven't done anything on my calculator until I've got to this very last point of the calculation to avoid those rounding errors. So let's go to the calculator and work this out. Okay, so let's just pop this in carefully. So we have 1/3 first of all. It's all about it being accurate here. Then we've got pi, and let's just check. So we've got 11 over 3. So notice as I'm going through this, I am checking very carefully to make sure I'm writing this in. And then we've got our square root, so control square root. Again, 8 squared minus, making sure we write this in nice and carefully. And one of the benefits of using this calculator, as you're going to see in a moment, is if you want to put brackets in afterwards, say I forget them. So one of the benefits of this, you can just put bracket there and it will automatically put brackets in. However, sometimes it's not so clever and you have to help it put brackets around the right part because you want all that squared. And notice I'd always do a double check at this point. Look at this calculation. Look at what I have. Is it the same? Yes, it is. We press the enter button and we get to our final answer here of 27.3014. Now, if this happens in the exam and you get the incorrect answer, then you have to go back and go, okay, what mistake did I make here? Well, I forgot to square the 11 over 3. So one thing to do here is actually check the estimating part of this. If you imagine you take the area of the base, which if we approximate this, if we know that 3.67, again, area is pi r squared. So again, I'm doing an estimating approach here. This is roughly 3. This is also roughly 3. And then this gives me 27 just for the base alone. So getting the answer that I did, because I'm going to times it by a height, that doesn't sound reasonable. So if that's happening to you, then you need to go through the formula and go, okay, where did I make the mistake? And the mistake here was forgetting to square the 11 over 3. So let's go back to the calculator and pop that back in. Okay, so what I'm going to do is just going to copy and paste this. I mean, I could have edited this out of the video, but I think it's good for yourself to actually see, okay, I'm not convinced the answer is correct. It doesn't seem correct from the other things that I know about this problem. Go back through, check and see, okay, that's where the mistake was made. So if I put this in, now I get to the correct answer of 100.1. So it's going to pop that in. Okay, so I'm going to keep this to one decimal place here. So we're going to put this in as 100.1 cubic centimeters. Now you can check the answers here. You can see the rounding, as long as you round something sensible, you are going to get all the answers there. Notice you get 3 method marks for writing the exact calculation that I did. And those are the answers there for question 9A and 9B. But it's really important as you go through a problem, you don't switch off that brain, you don't just rely on the formula, you think, okay, is that giving me a sensible answer? No, it isn't. What could be missing from it? Right, let's move on to another question 11, so 2 question 11s. And in the diagram, ADC is a straight line. Now that is important a bit later on. The first thing we need to do here is calculate AB. So as soon as you see this right angle triangle, you need to be thinking Pythagoras or trigonometry. Here we have one side and one angle, looking to find another side, so trigonometry is called for. Once we know it's trigonometry, then we have to label our sides. It's our first step that we do. So this here, this new x is opposite the angle, so this is O. This 8 here is next to the angle, so I'm going to put an A here. And again, we use SOHCAHTOA, so which of those has an OA in it? Well, that's going to be tan again, so we're going to use tan twice in this video so far. And again, we need to know these formula triangles. And this time we are looking for the opposite, so this is the thing that we don't know. So we cross out this part here, and then we're going to do the calculation we see, which is tan of the angle times adjacent. So to work out AB, we are going to do tan 34 times 8. So I've shown my calculation for the method mark. Let's go to my calculator and work it out. So we're going to type in, we can use TAN or we can press the trig button, tan 34 multiplied by 8, enter, and we get our answer of 5.396. So I'm going to write down 5.396 dot dot dot. Again, we want to round, as always, to 3 significant figures. So 1, 2, 3. We round the 9 upwards, so that's going to give us 5.40. Again, we have to be very precise in the rounding that we do to guarantee that we get all the method marks. Now we need to work out the angle DBC, and it's a whopping 5 marks, so you know there's going to be quite a bit of work involved in order to work out DBC. Now, how do I know where DBC is? Well, the middle letter always tells me where the angle is, and the sides tell me, okay, how do I get there? So DBC, it's going to be this angle that we're looking for here. Now back to my point here, ADC is a straight line. Therefore, I know that these two angles, so this angle plus this angle, add up to 180. So to work out this angle here, I'm just going to do a very quick calculation of 180 minus 34, and that's going to give me 146 degrees. So I'm just going to pop that in. Again, always use a calculator if you're not sure about that calculation. And then we look at the problem here and go, well, we've got a side and an angle. We're looking for this particular angle here, but at the moment we can't work that out directly. However, we can use this side over here. We can use this 8 to help us work out this one. So if we go through the process again, we have an angle and a side. We have a side and then a missing angle here. What does that call for here? Well, there's no more SOHCAHTOA, there's no right angle triangle, so we're going to use either the sine rule or the cosine rule. This is a situation for the sine rule. Now, what is the sine rule? Well, this is on your formula sheet. Sine A over A equals sine B over B. So we just need to label this up correctly just so we know which one is which. So just to stop any confusion here, I would rub that out, but I can't. So let me use a different color. So we're going to make this our big A because we know, we're going to make the angle that we don't know, big A. So then I make this one big A. This makes this then small a. And then we're going to make this big B and then make this small b. If we label it correctly, it makes the working we're going to do just now a little bit easier for us. So let's go through this process. So we've got sine A divided by the side opposite it, so that's the 8 over here. And that's equal to sine of the angle here, so that's sine 146 divided by 19. And generally when I have this kind of problem, we want to try and get the A on its own, or the sine A on its own. So we look at the left-hand side and go, well, what's the opposite of dividing by 8? Well, we need to multiply by 8 on both sides. This has the effect of cancelling here. So we get sine A is equal to, well, 8 times sine 146 is exactly that, divided by 19. And we can simplify this slightly further before we actually go on to use our calculator. So then we have the sine of the angle. So what's the opposite of sining? Well, that's going to be the inverse sine, and remember we do that to both sides, so that's going to give us a, because this part and this part cancel, and so we get the sine inverse of 8 sine 146 over 19. And notice I haven't rushed to my calculator here until I've got it in a form that I like and try and minimize any of those rounding errors as we go through the problem. So I'm going to go to my calculator and work this out. So where is the inverse sine button? Well, all you have to do is go to trig here and you'll find there's a sine minus 1 button under here. So that's where our inverse sine function is. To make a fraction, we just go to control and divide. That gives us our fraction. And then we just type it in. Notice I can type in sin and it will recognize the function. I do love this TI Inspire calculator. And put 19 at the bottom. If we work this out, we get the angle of 13.618. So let me write that in. 13.618 dot dot dot. So that's the angle here. 618 dot dot dot. Now, of course, that is not the answer that we're looking for here. We are looking for the angle DBC, but now we can use the idea that angles in a triangle add up to 180 degrees. So to work out this final angle, so DBC, we just do 180 minus the two angles that we do know, so 146 plus 13.618 dot dot dot. Again, trying to avoid those rounding errors by keeping as many decimals in as possible. So let's go back to my calculator. So all I'm going to do here, I'm going to do 180 minus, open brackets, 146 plus answer, so control answer. This allows me to get the most accurate answer possible for this particular question. So if I work this out, I then get my final answer of 20.38. 20.38 dot dot dot. And of course we always round to 3 significant figures, so our final answer will then be 20.4 degrees for our 5 marks. Now, I think maybe this should be a 4-mark question personally, but again, there's quite a lot to consider here. First of all, the angles on a straight line, then using the sine rule for an angle correctly, and then realizing we need to use angles in a triangle to find our very final answer of 20.4. Now, we're going to use this a little bit in the next question as well. So now we need to calculate the area of triangle ABC. Now, just keep in mind here that the triangle ABC, so if I do this in a different color, let's do some yellow, is the entire triangle that we see in front of us. So it's this part, and this part here. So we try and find the whole triangle together. Now the easiest way of doing this is to use that formula from the formula sheet that we haven't mentioned yet. So the area is equal to a half AB sine C, where A and B are two sides and the C angle is in the middle. Now the one that comes to mind here is to use some of the things that we already have. So I'm going to use this big angle here as my angle in the middle, my C. As X we already worked out from the previous question, 5.40. We know 19 from the question itself. And because we worked out this angle, notice these questions lead into, we actually know that this angle here, the whole angle, is going to be 90 plus the answer we just worked out, 38 dot dot dot, which is going to be equal to 110.38 dot dot dot. So let's bring all this together for our formula. So the area of the triangle, I'm just going to write down to the examiner that I know what it is, half AB sine C. And let's just pop in all the numbers that we have. So half times, well, we know what X was, that was the 5.396 dot dot dot. We know that the B side would be 19, so times 19, and then times the sine of the angle in between, so that's 110.38 dot dot dot. Notice with this kind of question, they are usually quite lenient in if the answer is not exactly accurate, they'll still give you all 2 marks. Let's try and make it, though, as accurate as possible. So we have 0, oops, there we go. So 0.5 times 5.396. Probably should be using a few more decimal places, but we'll use this for the moment, 19 times, and we want to use sine here, of 90 plus answer, because the answer from before was that smallish angle that we had. So I'm going to try and use that just to minimize any rounding errors. So I think we've got everything there, and then we get to our final answer of 48.052. 48.052, and that rounds then to 48.1. So let's just check the mark scheme, make sure that's accurate enough for the mark scheme. Yes, it is. You can see actually it should be between these two numbers. So both 48.0 or 48.1 is correct. But the best thing to do is try and keep as many decimals in the question as possible, just so you don't miss on any accuracy marks at the end. Notice with the mark scheme here, they give you a range to get it between. So 48.04 and 48.12, which we certainly fit into with our answer of 48.052. So again, try and keep those questions as accurate as possible. On to our next question, which is a paper 4 style question. So there's lots of subparts as we go through. The first part is a little twist on what we've seen so far. So AB is a line with midpoint M. A is the point 2,3. M, so the actual midpoint now, is 12,7. And we need to work out the coordinates of B. So imagine you've got a coordinate, 2,3. Imagine you've got the midpoint, which is 12,7, and then you want to work out what this point B is. So I tend to like visualizing these kind of problems. You're going to see that kind of method as we go through. So imagine I connect all these up in a nice straight line. Well, then I look to myself, well, what's the gap between 2 and 12? Well, I need to add 10. So because this is the midpoint, I need to add 10 again, and that's going to give me 12 plus 10, which is 22. And I do the same trick here. So what do I add to 3 to get to 7? Well, add 4. So I need to add 4 to that, and 7 plus 4 is equal to 11. So by drawing a diagram, you can make your life much easier with these kinds of questions. Try not to learn just formulae off by heart. Again, visualizing the problem is going to help you in those A-level studies and IB studies afterwards. And now, from this, somehow, we need to work out that the equation of the perpendicular bisector, we're going to see this a ton on this particular video, is this equation over here. Right, so as soon as I see perpendicular bisector, I want to get everything set up. So remember, A again was 2, 3, and then B was 22, 11. So this is what we're focusing on for this particular question. Again, we've got the midpoint, which we'll come back to later on. So keep that in mind. As soon as I see perpendicular bisector, so I see that phrase, there is a 3-4 step procedure which will work it out for you. The first thing that we need to do is work out the gradient, the steepness of AB. Now you can draw this visually. I'm going to teach you a formula on this one which is going to make your life easier, and that is y2 minus y1 over x2 minus x1. In other words, the change in y over the change in x. And the key thing here is not to get confused which one is which. So I tend to do a bit of highlighting here to make our life a bit easier. So if we take the 2 and the 22, so the x part of it, that's going to be our, and it doesn't matter which way round we do this, this is going to be our x1, and that's going to be our x2. And then the 3, so let's get the highlighter out and use a different color. Yeah, let's use blue. So you've got 3 and 11. That's going to be then, the pen out, y1 and y2. So labeling those coordinates is really, really important so you don't make mistakes in working out the gradient, the steepness of the line. So if we do this and follow this, so we get y2 is 11, y1 is 3, and then x2 is 22. I'm just being very careful here, and then x1 is 2. So if we work this out, 11 minus 3, that's equal to 8. And 22 minus 2 is equal to 20. And you should always simplify your fractions when you get the chance. Notice 4 goes into both here, so we're practicing other skills from the course. So we're going to divide top and bottom by 4 to get a simplified fraction. 8 divided by 4, that's equal to 2. 20 divided by 4, how many 4s in 20? That's going to give you 5. So the first step is to work out the gradient. Now step 2 would normally be to work out the midpoint, but we already have that in the question, which is very useful. So I'm going to write it down again. So our midpoint here is 12.7. We'll come back to that in a moment. Step 3 is a step that we've already seen in the previous question. Because we're looking for the perpendicular at right angles, bisector, we want again that negative reciprocal. Again, you're going to hear that phrase a lot. This is slightly different to the previous question because our gradient, what we need to do, because we already have a fraction, is we're going to flip that fraction and then turn it negative. So we're going to take the 2/5, we're going to flip the fraction, so that gives us 5/2, and then make it negative. So that gives us the gradient of the perpendicular bisector. So what that means is that y is equal to minus 5/2x plus c. Very similar to how we did that kite question earlier. Now, because we've got a bisector, it wants to go through the middle. It wants to split the line into 2 equal parts. Therefore, we know that the perpendicular bisector and the original line, they share this midpoint 12.7. So we can substitute that in to work out the c. So let's do that over here. So when x is equal to 12, because that's the x part here, then y is equal to 7. We pop that in, so we get 7. So I'm just copying this equation. Wherever I see a y, I put a 7. And wherever I see an x, I'm going to put a 12. And now it's a case of making c the subject. So if we do this part here, you can do this without a calculator as well. Well, notice that you can actually cancel here. So 12 divided by 2 is equal to 6. Minus 5 times 6 is equal to minus 30. And therefore, if we want to work out c on its own, what's the opposite of minus 30? Well, adding 30 on both sides. That gives us then 37 is equal to c. So our answer in y equals mx plus c form is going to be y equals minus 5/2x plus 37. Now you might think that's the answer at this point, but notice they want it written in this kind of strange way over here. So we're going to have to do a little bit of massaging to get it in the form that they want. So let's create a little bit of room for ourselves. So we've got plenty of space to do this. So I'm just going to copy this across. So minus y equals minus 5/2x plus 37. Again, I like to call this massaging, just massaging it so we get it looking like the box here. Now, the first thing I notice is we actually have a 2y, not a single y. So the first thing that comes to mind is, let's just multiply everything by 2. Because that's going to guarantee us that we get 2y, because 2 times y is 2y. The times 2, well, that's going to cancel with the 2 down the bottom. That gives us minus 5x. And don't forget to multiply this 37 by 2 as well. 37 times 2, do it on your calculator, is 74. And suddenly, we get something very, very similar to the box. But we just need to do one tiny thing here, which is bring the x over to the other side. So what's the opposite of minus 5x? Well, plus 5x on both sides. That's going to give us 2y plus 5x is equal to, well, that cancels. So we get 74. And it's a great feeling in the exam when this happens, because you know by getting to the correct answer here, you have guaranteed all 4 marks for this particular question. And remember, this is a paper 4 question, so it's going to continue as we go through. So just to remind us, the perpendicular bisector, so I'm going to put PB, is what we just worked out. So 2y plus 5x is equal to 74. Super. So the perpendicular bisector of AB passes through the point N. The point N has the coordinates 2, n. Find the value of n. So we're given the x-coordinate here. So we're told the x-coordinates, and it wants us to work out the y-coordinate. So when x is equal to 2, we're going to copy out what we've just done. Wherever we see an x, we're going to put a 2 and then solve. So we get 2y plus 5 lots of 2 equal to 74. And then we just need to work through the algebra. So we have 2y plus, well, 5 times 2 is 10 is equal to 74. And when you get to this stage, it's nice and relaxing getting through to y. So we're going to minus 10 from both sides. Again, the opposite operations here. That gives us, this cancels, 2y is equal to 64. And then the opposite of timesing by 2 is dividing by 2. That's going to give us then y is equal to half of 64, which is equal to 32. So a 1-mark question. Again, if you can get to the answer directly without showing that working, that is absolutely fine as well. Right, so now we've got, again, slightly different question. They do this often on paper 4s. You know, the first parts, A, B, C, will be quite straightforward, but then D will be a little twist on what you've seen on the course. And points A, M, and N, they form a triangle, and you need to work out the area of the triangle. Whenever you get a problem like this, you're like, I'm not sure where to start with it, draw a diagram. Doesn't have to be the scale in the slightest. So let's go through our points. So A is 2, 3. So I'm just going to write down these points. M we worked out before, didn't we? It's 12, 7. And then N is equal to 2, 32. First thing I notice here is that the x-coordinates are the same for A and N, which is going to be very useful a bit later on. So let's draw a diagram here that looks reasonably accurate. Again, doesn't have to be to scale in the slightest, but to give us a good idea of what's going on. So A is 2, 3, so that's going to be somewhere here. N, notice, is 2, 32, so it's on the same horizontal line, just way over here. And then M is going to be 12, so in the middle somewhere, not exactly in the middle, that doesn't matter. And then further up, so other way round. So we've got 232, so let's do this again. So the x-coordinates are the same, and it's the y that differs. So we've got n way up here, and then we've got 12, which is over here, and then 7, which lies closer to this point, but again, it doesn't really matter. So we get a triangle. What's crucial here, and the first thing I notice in this question, this is A, this is N, this is M. This is a straight line upwards, which is going to make our life a lot easier actually calculating the area. Remember, the area of a triangle is the base, so this is going to be our base in this case, multiplied by the perpendicular height divided by 2. So let's work out these things. So our base is going to be the difference between 3 and 32. So that's going to be 29. This perpendicular height of it, well, it's going to go from 2 and it's going to go all the way to 12. So that's going to be 10. And that's all we need here. So in order to work out the area of the triangle, we're going to do a half 29 times 10. So again, we can do that on the calculator if you so wish. We can do a half of 290. Don't need a calculator though, that's going to be 145. So our final answer, again, it's all about drawing a diagram that makes sense. It's going to be 145. Notice there are no units in this particular question, so you don't have to put a square centimeters or square meters. Again, the diagram is really helpful here, and spotting that two of the points share the same x or even y coordinate would also work in the same way. That means that you can form a very easy equation then to solve to work out the area of the triangle. Okay, so you can check your answers here. Again, it's a very bizarre method that you could have used for part D, but I think drawing the diagram, visualizing, using that knowledge you've got from the course is a much easier method. Okay, and moving on to another question. So we've got our question 2A here, so we've got our grid which we're going to work on, and we're going to go through the following questions. So the first thing we need to do is draw the image of triangle T after a reflection in the line y equals x. So what does the line y equals x look like? Well, the coordinates have to be the same. So if we take this grid, for example, then 1 and 1. Y has to be the same as x. 2 and 2, 3 and 3, and also for the negatives as well. So minus 1 and minus 2 and 2, minus 3 and 3, minus 4 and 4. And we are reflecting triangle T. So we're focusing on that. So I'm just going to draw in this line just so we've got something to work with here. And when you have a diagonal line, one of the best strategies you can actually do is when you're in the exam, actually turn your page to make it a horizontal or vertical line, because it will make this next process much easier. So what we're going to do is we're going to take each corresponding point and then pop it over. So if we do that, we've got this point here, and we always want to meet the reflection line here perpendicular. So what do I mean by that? Well, if I take this diagonal like so, notice that this forms a right angle. So you know you are reflecting that line correctly. So we've got 1, 2, 3 diagonal. So we need to go 1, 2, 3 diagonal in the other direction. So 1, 2, 3. So that point comes to there. And we do the same process on each of these coordinates. So let's take this one here. Again, we want to go diagonal. So we go diagonal, 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 until we get to the reflection line. So let's see how many that is. That's 1, 2, 3, 4, 5, 6. So we go 6 again. So we go 1, 2, 3, 4, 5, 6. And then just to make sure we're doing everything correctly here, always take your time. We're going to do exactly the same process here with this green point. So we've got 1, 2, 3, 4, 5, 6, 7. And then we do 7 again. So we go 1, 2, 3, 4, 5, 6, 7. Almost therapeutic when you're doing this, yeah, particularly all the different colors. And now I'm just going to put my shape into red so I connect up all these points to give myself the triangle that I'm looking for. Again, I'm going to call this T dash to indicate that this is the image that I was looking for in this question. If you check the mark scheme, you see, you get 2 minus 1, 2 minus 4, and 3 minus 4, which lines up with what we got there. Okay, and on to part 2 here. So now we're going to draw the image of triangle T after a translation by the vector minus 1, 3. So notice they can ask these kind of questions in different ways. They can ask you to describe or actually do the transformation yourself. Remember, the top number indicates left or right. Because it's a negative, we are going to go 1 left. And the bottom number indicates up or down. Because this is positive, we're going to go 3 up. So we're going to take triangle T, and we're going to move it 1 left and then 3 up. Okay, I've got some space in my diagram, so that's fine. So let's take any point here. So let's take this point, and we are going to go 1 left and 3 up. Notice the coordinate grid is slightly different here. So 1 will actually be these 2 squares. So this is 1 left, and then 3 up will be 1, 2, and 3. Now, if you get confident with this kind of question, what you can actually do here is once you've got one of the points, you can actually draw in the rest. Remember, with a translation, there won't be any change to this particular shape. So this is still going to go up by 1. This is still going to go across by 3. So we've got 1, 2, 3. And then we can draw that in. Again, I'm going to label that T dash to indicate that I've translated the shape. So that's a quicker way of doing this kind of question when you're a bit more confident. But if you're not, you can do each coordinate individually, translate it, and then you know you've got the right answer. So we've got our minus 5, 6, which is the one at the top. And then we've got minus 2, 5 and minus 5, 5, which are these two here. And now we need to describe the single transformation that maps triangle T onto triangle A. So again, we want to go from T to A in this case. I'm going to wipe off the board so we've got a bit of space to find this either reflection or rotation. Okay, so hopefully I caught you out there. It actually isn't a reflection or a rotation. Now, how do I know this? Well, one thing you should always check is the length of the sides. So the length of this side is 2, whereas the length of this side is not exactly the same triangle. This is actually 3. So the way that we actually find out the scale factor is just simply do big divided by small, because we're going from t to a. So the scale factor is going to be 3 over 2, or equal to 1.5. So actually in this case we don't have a rotation or reflection, we actually have an enlargement. So that is going to be with a scale factor of 1.5. However, it doesn't necessarily have to be positive 1.5. If it was, then it would be coming outwards probably, and therefore it would be a positive enlargement. Because we have this kind of reflection or rotation idea, it needs to be negative. So we've actually got a negative enlargement here of minus 1.5. So these are two things we can write in. We have an enlargement first of all, and this is with a scale factor of negative 1.5. However, just like with a rotation, we need to find the center of it. So in this case, the center of enlargement. And the way that we do this is slightly easier than if we actually had a rotation. So what we do is find corresponding points of our shape here. So notice that we've got the right angle here and the right angle here. And what we're going to do is connect those up together. So if we do that, we are going from minus 4 to 10, and then we are going from 2 to 4.5. So we want to try and draw this with a ruler as accurate as possible. I don't have a ruler in this case, so what I will do to make my life a bit easier is actually mark in the midpoint. So the midpoint between them. So we know it's going to be at 2. So it's going to be at 1. Because that's halfway between minus 4 and 6. And if we look at this scale, so between 2 and 4.5, that's a little bit more tricky because that's going to be a gap of 2.5. So we're actually looking for then 1.25 in between. So that's going to be at 3.25. So that just gives me a bit of guidance when I actually draw this in. So let's now draw in this particular line. Try and make this as straight as possible because otherwise it's going to be hard to identify the center of enlargement. Here we have something slightly easier to work with. So if we take those 2 points here between minus 1 and 1.5, again we are going to get a gap here, or a slight gap of 1.5, 2.5. So again we want that 1.25 in between. So that's going to be at 0, 2.25, and if we're working upwards, so between, it's going to be the same as before, so 2 and 5, so it'll be at the same height. So what we can do here is we can pop that in, and then we're going to draw in our dotted line like so. And now we can do the same with the very last point here, so we've got this point, and this corresponds, if you think about the rotation effect, to this point, and so we pop that in like so. Now the key thing is to do this with a ruler because a clear point then comes in terms of our rotation point. I think we can see here that most of the lines here do cross here. If you do this more accurately, we will get this, and so this is going to be our negative enlargement point, which is at 0, 3. So we pop that in and just say the center of enlargement is at 0, 3. Just point about the mark scheme here, so you get B1 for each here, so 1 for enlargement. You don't have to put scale factor, but I think it's good practice, of minus 1.5, and then the center of 0, 3. This shows the disadvantage of doing this without a ruler. If you do that, you can see the lines don't quite cross at 0, 3, and it becomes harder to actually find that rotation point. Sorry, that center of enlargement point. So make sure you do that at home and use a ruler. And now we've got a nice little twist here with similarity and scale factors to finish off. So quadrilateral P is enlarged by a scale factor of 1.2 to give quadrilateral Q, and we're told the area of quadrilateral P is 20 square centimeters. Calculate the area of quadrilateral Q. So even within a transformations question, they are really testing your knowledge of other areas of the course. Now, of course, we've got an area, so we actually want the area scale factor. And the area scale factor will be the one that we're given, but we need to square it. So if we square 1.2 squared, turn on the calculator, then we get the number of 1.44. This is where we have to be very careful. And now we want to find the area of quadrilateral Q. So to find the area of Q, we take the 20 that we got before, and then we times by 1.44. The biggest mistake students make on this kind of question is timesing by 1.2. Now if we do that on our calculator, this is a calculator paper, then we get our answer of 28.8, which I'll just pop in here for the 2 marks. Okay, so you can check your answers, so you can look at the mark scheme now in a bit more depth. Again, you get a method mark for identifying this idea of doing 1.2 all squared. If you're liking the content so far and the way that you're being presented with transformations, then do like the video. It's the best thing that you can do, and that helps it spread to more people and hopefully help them with their iGCSE exams as well. Okay, on to the next question. So again, this is very, very typical of the paper 4 and the 0580 course. They don't start necessarily with a differentiation problem. It's usually embedded in another question. So in this case, the equation, this cubic, x cubed minus 4x squared plus 4x, can be written in this form. Find the value of a. So cubics, generally speaking, will be written in such a way so you can factorize this quite easily. So notice they've all got a factor of x here. So we're going to take a factor of x out. What do you multiply x by to get x cubed? X squared. What do you multiply x by to get minus 4x squared? Minus 4x. What do you multiply x by to get 4x? It's just plus 4. At this point, we've got a quadratic within the bracket. So at this point, we can put this into 2 brackets. And we put an x at the front, an x at the front. And we want 2 numbers that multiply to give me 4, but add to give me minus 4. Well, that's going to be minus 2 and minus 2. And notice, because you've got 2 x minus 2's, this can be simplified further as x minus 2 squared. Now, that's not the answer that they're looking for. The actual answer is, what's this missing value a here? And notice it's the value of 2. Now, one of the reasons they've done this in the first part is now we can now draw a very nice sketch. So if I was to solve this equation, so let me pop this over here. So x over x minus 2 all squared times x minus 2 all squared is equal to 0. Then using the null law, I know then that x must be either equal to 0 or equal to 2. However, this is a cubic. So remember that the shape of a cubic, generally speaking, looks something like this. So it crosses the axis 3 times. This is a very special cubic where it only crosses or touches the x-axis twice. So let's mark in those turning points. So we've got 0 here and 2 over here. We have a positive cubic. Notice this is an x cubed. And so we've got all the information we need to draw a good sketch. So watch carefully. We're going to go up, 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 up. We go through the point. And this is the crucial part. Because 2 is a repeated root, we're just going to touch the graph there. And then we go off. That's a little bit of a bend there. Try and make sure that's a nice smooth curve as well. Okay, so notice that I've followed the instructions of the question where the graph meets the axes, where it meets it at 0, 0, meets at 2, 0 as well. But there is some sort of local maximum, but that's not necessary for this question. You'll see in the mark scheme, if I go forward to the mark scheme. So here's your graph. So it's going through the origin, going through 2, 0, the positive cubic, and it's the right shape as well. So you can see I pick up all 4 marks. Now comes to the differentiation part. So they take that cubic and we want to find the equation of the tangent to the graph at x equals 4. So what that means in real English is if I take green, x is 4 is probably up here somewhere. Okay, so if we read that off, that's 4. So basically at that particular point we want to find the tangent line. So the line that just touches the curve and then disappears off. So this really, really steep line. And we want to find that equation of that particular line. So the way we do this is we use some differentiation. This is where it's embedded. So first of all, we need to differentiate the function. So we get dy by dx. So remember, we take the 3, bring it to the front, reduce it by 1. So we get 3x squared. We do the same procedure here. I'm speeding up slightly now. So minus 4 times 2 is equal to minus 8. Reduce the index by 1 is 8x. And don't forget, because you've got a 4x here, we do the same procedure because this is a 1. 1 times 4 is 4. And then reduce the index by 1. That's x to the power of 0, which is just 1. So we get the function of dy by dx is equal to 3x squared minus 8x plus 4. Now at this point, we actually want to work out the gradient at the specific point. We don't want to work out turning points or anything. So we need to work out d by dx, where x is equal to 4. What does that mean in real English? Well, we're going to put 4 into this equation. So we get 3 lots of 4 squared minus 8 times 4 plus 4. Well, 4 squared is 16. 16 times 3 is 48. 8 times 4 is 32. Plus 4. And that simplifies to 20. Okay. So the gradient of that green line that I drew over here, let me just mark this in. The gradient of this line is equal to 20. So we've got that information. Now that means that the tangent line, so I'm going to write the word tangent, has the form y equals 20x plus c. And now we need to work out the y-intercept, this c. Now the only point that we know on this particular tangent line is this point here. Okay, and we know the x-coordinate is 4, but we currently don't know what the y-coordinate is. The way we can work that out is actually substitute x equals 4 into this equation. So when x is equal to 4, y is equal to 4 cubed minus 4 lots of 4 squared plus 4 times 4. That's a lot of 4s. That is definitely a lot of 4s. So we get 4 cubed is equal to 64. Well, 4 squared is 16. 16 times 4 is 64. Oh, that's nice. That cancels. And then we get 4 times 4 is 16. So when x is 4, y is 16. So this coordinate is actually 416. And now we have enough information to work out c. So when x is equal to 4, y is equal to 16. You can see why this is a 7-mark question. A lot of work involved. So we've got 16 equals 20 lots of 4 plus c. So 16 is equal to 80 plus c. And then c is equal to 16 minus 80. This is really where you don't want to make a silly mistake, by the way. So 16 minus 80, that's equal to minus 64. So our final answer is equal to y equals 20x minus 64. And you'll see that agrees with the final answer at the end for all 7 marks. So just be very careful of that kind of calculation right at the end. You're going to be tired at the end of a question like this. Make sure you're accurate all the way until the end. Okay, and here's another very typical paper 4 question with differentiation integrated in there. We're going to do some work with curves. So we've got the sketch of the curve x squared plus 3x minus 4, and we need to find the coordinates of a, b, and c. Well, c is the easiest one because that is the y-intercept. So the y-intercept, remember, is just the number at the end of the quadratic, so this one here. So that's going to be 0 minus 4. So that was easier to work out. The a and b are what's known as the roots of the equation, and we work those out by taking our quadratic and making it equal to 0. So then we can actually factorize this. Of course, you can use the formula if you so wish. And the way I tend to solve these is I look for 2 numbers that multiply to give me minus 4, add to give me plus 3. And the numbers that seem to work here are plus 4 and minus 1. 4 minus 1 is 3. 4 times minus 1 is minus 4. I need to solve this. Well, either x minus 1 is equal to 0, so x is 1, or x plus 4 is equal to 0, and x is minus 4. So then we've got the x coordinates of the two roots. So a is, remember, is more on the left hand side, so that's going to be minus 4, 0, and then because this is in the positive quadrant, b is going to be 1, 0. So don't be surprised if there is something else within the differentiation question. So if they get you to work with some graphs, cubics, quadratics, etc. Make sure you're happy with those kind of questions. Now we need to differentiate our function. So we're going to work out what dy by dx is. Well, remember, take the 2. Probably sound like a broken record at this point. Bring it to the back, so we get 2x. And then if you differentiate something with just a single x, of course, we just get the number in front. So we get 2x plus 3. So let's make sure we write that in the right place. And once we've done that, then we want to find the equation of the tangent to the curve at the point 2, 6. Okay, so essentially what we're doing, if I represent this, is if we take the point 2, it's going to be up here somewhere, then we want to find this tangent line that just touches the graph and then disappears off. Obviously it doesn't bend in the middle, a nice straight line. So what we do is we work out the gradient at x is equal to 2. That comes from this coordinate here. So I'm going to take my answer here, 2x plus 3, and replace the x with a 2. That gives me 2 times 2 is 4, 4 plus 3 is 7. So that's going to be the gradient of the tangent line. So I'm going to write this in words, like so. And therefore, this gradient, this tangent line, is going to have the equation of y equals 7x plus c. We have a nice coordinate given already, which is very, very helpful. So we can actually work out the c. So when x is equal to 2, y is equal to 6. So we get 6 is equal to 7 times 2, which is going to be 14. And then to work out c, we're going to minus 14 from both sides. And that's going to give us minus 8. So our final answer is going to be y is equal to 7x minus 8. 3-mark question, and one of the reasons it's a little bit less than the previous question we looked at is they already gave us one of the points already on the tangent line. So you can check your answers, you can have a look through what I've just done. Again, typical paper 4 question. I'm really trying to give you as much exposure to 0580 differentiation questions as I can, so you're ready for lots of different situations that can arise. Okay, and on to question 7. So we have a negative quadratic here, y equals 10 minus 8x squared. Anything with ax squared in we call a quadratic. And the first thing we need to do is identify the symmetry or the line of symmetry of the graph. Now I think most of us can see this straight away, that the line down the middle would be the line that splits the curve into 2 equal parts. The tricky part is actually identifying the name of this line. And the way to do this is just take random coordinates on this line. So for example here, this is the coordinate 0, 8. So 0 along and 8 upwards. This would be 0, 6. If you go down here, this would be 0, minus 2. And the way I remember this is, what do they all have in common? And they all have the x coordinate, not the y, but the x coordinate as 0. Therefore, we call this line just simply x equals 0, like so. So if you get confused, okay, what name do you give to a vertical line or a horizontal line? Put some coordinates in and then try and see the pattern that's going on if you find that tricky to remember. Now on the grid opposite, we need to draw the tangent, we saw that word in the very first question, to the curve at the point where x is equal to 0.5. And once we've drawn that tangent line, then we need to find the gradient of this tangent. Now, like one of the previous questions, we do actually get a range of answers in which we are allowed to have. So as long as we draw an accurate diagram, we should get to that. Now, what do we actually need to do? Well, first of all, we identify x equals 0.5. I'm going to rub out what I did before, so we've got plenty of space. So all we do is go along to 0.5 and we go all the way along upwards until we touch the curve, which is at 8. So that's helpful. Okay. And what the question wants us to do here is draw a straight line that just touches the curve. Now this is obviously much easier to do here with a ruler rather than by eye, which is what I'm going to do here. But I'm going to try this. So I'm going to draw my straight line. Let's see how much success I have here. So I'm just going to touch it, just touch it, and then off I go. Okay, I think that's reasonable. It's probably not the best in the world, but certainly not too bad. Now, what we do at this point is we try and use sensible points in order to work out the gradient. So what do I mean by sensible points? Well, something that's going to make our life a lot easier. Notice we've got 1 here and 0. That's going to make our life a lot easier. So if I go up to 1, which hopefully my eyesight is fine. So here's at 1. This is what my tangent line is. It might be different for you at home. And what I'm going to do is make a right angle triangle from using this as the hypotenuse. Now, okay, what does that actually mean? Well, I'm going to draw a straight line across from 4 that connects with that point, and then I'm going to make a triangle like this. So the way to make work out the gradient is to create a right angle triangle and to make the numbers as easy as possible for you. Now, you can do any size of triangle. I've done this quite large one because it's going to make my calculation easier later. Now, let's see why that's the case. So first of all, I'm going to identify how long this is. So the length from here, from 0 to 1 is just 1. And the length from 4 to 12, that's equal to 8. So to work out the gradient of the line, so this is the m, remember it's that rise over run. Or other people use the change in y over the change in x, or even the formula as well, which I always forget, which is why I don't use the formula. So change in y over change in x. Now what does that actually mean? Well, okay, we're going downwards because this line is facing downwards. So to go from 12 to 4, that's going to be -8. And then we've got, okay, divided by a change in x, which is just 1. So the gradient of our line is going to be equal to -8. And this is why I chose 1 for this length here, because it makes this calculation really, really easy to do. So, of course, I'd write this calculation, what I just did here. The gradient is equal to -8 in this space provided here for part B. Now, if you look at the mark scheme here, any answer between -9 and -6.5 is valid, as long as you've shown a method like I have for this particular question. So well done if you got like -7, -7.5, that's probably even better. So well done on that. But again, you have to go through these steps and make sure you're getting the method marks here as well, just in the way that I did here. So once we've done that, then we've got another table of values question, and this is a bit more complicated. We've got a more complicated cubic function here. It's x cubed plus 3x plus 4, and we need to work out more of the gaps here. So the first thing we need to do is complete the table. Now I'm actually going to use the calculator this time to actually work out each of these numbers. Okay, so I've got a calculator here. Again, I'm just going to use the normal function here. I'm not using anything graphical calculator-wise because you wouldn't be allowed to in the exam. So the first thing we need to do is put -1 into here. So wherever I see a -1, an x, I'm going to put a -1. So we put bracket -1 cubed, making sure we do this correctly, plus 3 lots, open brackets, -1, close brackets, plus 4, and then we get the answer of 0. Always do a double check, a sense check here. So -1 minus 3 is -4 plus 4 is 0. So I'm happy with that. So let's pop that in. Now I've got -0.5. So I'm going to do the same calculation here. And hopefully don't get beeped at by my laptop. So 0.5. Again, we want the cube button. Just take your time with this. Yeah, just make sure you're doing everything correctly and not making any mistakes. So you can see I'm just taking my time. You get 3 marks for this. You get plenty of time in the exam to do this. Okay, I'm getting 2.375. Let me just double check this. Okay, 2.4 or better. Yeah, that's fine. I would write in the precise value, particularly something that doesn't require much rounding. And 0 here we can do a little bit of common sense, because when x is 0, this disappears, and we're left with 4. So notice you don't have to always rush to your calculator with these questions. Now on the grid opposite, and that's always a groan, particularly in the exam because you have to turn between the 2 pages of your exam, draw this graph between minus 1.5 and 1.5. So let's just do this precisely. So we've got minus 1.5 and minus 3.9. Minus 1.5 and minus 3.9. One thing to check here is the scale. So I think it's going in 0.2s, 2, 4, 6, 8, 7, 4, 6, 8, 8. Yeah, so 0.2s. So just keep that in mind. So minus 1.5, and we want, there's minus 4, and we want minus 3.9. So it's going to be there. Again, try and do this as accurately as you can. We'll do this function in red. Okay, so that's minus 1.5 minus 3.9. Minus 1, 0. That's nice and easy. So that goes there. Minus 0.5, 2.375. Again, about 2.4 basically. So it's going up in 0.2, so that's going to come here. 0.4, that's nice and easy. That's here. Probably local maximum, I'm guessing. 0.5, 5.6 on. Okay, bad guess. So 0.5 is here, and then 5.6. So 2, 4, 6, 8, 5, 5.4, 5.6. Maybe that's going to be our local maximum. Okay, or maybe not at all. And next one, 1.8. That's a nice easy one to do. So 1 along. This is where the line from before is not very helpful. And then we get to 8. Okay, so we're getting sort of a slight bend at this point. So we've had a point of inflection. And 1.5, 11.9. 1.5. Okay, it's basically at the top here. And now it's the fun part of nice smooth curve. So we're going to do our best to do a smooth curve here. So let's see how we get on. So up we go. Through we go. Through a point of inflection. Almost got through that one, and there we are. So we do get our strange cubic function. So we get a graph that looks pretty reasonable to me. And we get 4 marks for that. So make sure you really do this accurately and make sure you get all those marks. And now we need to show that the values of x where the 2 curves intersect are the solutions to this random equation. Now, when 2 curves intersect, basically you make them equal to each other. So what we're saying here is that this curve, so this cubic curve, so x cubed plus 3x plus 4 is equal to the quadratic right at the start, so 10 minus 8x squared. So that is what it means when they intersect, when 2 curves intersect. You just make the 2 functions equal to each other. And now we just need to rearrange this to get it in the same form that we have here. So the first thing I'm going to do here is add 8x squared on both sides. And you could do this in one step if you so wish. If you add 8x squared, then all we get is 8x squared. Remember, it doesn't collect with anything here. So x cubed plus 8x squared plus 3x plus 4 is equal to 10. These two things cancels. And then finally, we just need to minus 10 from both sides. And if we do that, that does collect with the last term. So get x cubed plus 8x squared plus 3x. 4 minus 10 is minus 6. You can kind of cheat and just check with the answer that you do get what you do. And 10 minus 10 is equal to 0. So that's just a realization that when 2 curves intersect, one curve equals the second curve, and then a little bit of rearrangement afterwards. And I like question E. So by drawing a suitable straight line, so they're giving a kind of clue what to do here, solve this equation. And the first thing you notice here is, okay, x cubed plus 5x plus 2 is equal to 0. That's not what I had before. The equation that I had before was x cubed plus 3x plus 4. So this is what I had. I'm going to write that down. What I had. And what we want to get to is x cubed plus 5x plus 2. So then we have to think to ourselves, okay, how do I go between one and the other? And probably should put the arrow the other way round here, because essentially what we're trying to do here is make this one look like this. And the difference between this is, well, we have a minus 2x. To go from 5x to 3x, we have a minus 2x. And to go from 2 to 4, we just add 2. So this is an important expression. I'm going to show you why this works now. So imagine I put x cubed plus 3x plus 4 is equal to minus 2x plus 2. Imagine I did that. That's essentially where the two curves intersect, and that's essentially going to solve the equation. But I can rearrange this equation to make the right-hand side 0 by adding 2x and minusing 2. So if I add 2x and minus 2 on both sides, notice I get to the cubic that we're actually looking for. So we get x cubed plus 5x minus 2 on this side, and then this cancels, and get equal to 0. So these two things are equivalent. So if I draw this line, the minus 2x plus 2, and find the intersection points with the original cubic, then I can solve this actual different equation up on the board. So the next thing we need to do here is draw the line minus 2x plus 2. There are different ways that your teacher can teach you to actually draw this line y equals minus 2x plus 2. Now if I've got a choice, I tend to do the so-called lazy solution. Now what is the lazy solution? Well, I put in x is 0 to start with, and then see what I get for y. So when x is 0, that disappears. I get y is equal to 2, also known as the y-intercept. I'm sure other teachers have done that before for you. And I can do it the other way around. So when y is equal to 0, a bit more calculation involved, then that means that 0 is equal to minus 2x plus 2. And therefore I can rearrange this equation very quickly to give me x is equal to 1. So I know these are 2 points, so 1, 0 and 0, 2 are 2 points on this straight line. Let me write it in coordinates, 0, 2, and then be careful here, this is 1, 0. So if I've got a ruler in the exam, all I need to do, I'll use a different colour here. So here's this blue colour. So I've got 1, 0, so let's put in point 1, 0, which is just here, and I've got 0, 2, which is this one here. And all I need to do is just join those points up and then just continue the line all the way through. Okay, so I'm going to connect these lines up best I can and then just continue all the way through. And likewise here, all you do is just continue this line all the way through, like so, and try and keep the same gradient. With a ruler, of course, this is much easier. Once you've done this, then notice this function here, this is the one that we drew, this cubic. So this red function is that x cubed, what was it again? Plus 3x plus 4. This blue line I've just drawn is that minus 2x plus 2, the kind of cheat way of doing it. And then all we need to do is find that intersection point and then read off the x value. So let me do this in black. So I found the intersection point, and all I need to do at this point is just go down. Remember, there's only one intersection point here, by the way. And just go down and then read off that value. So I'm getting the value of, and let's just again double check the scale here. I think it's going in 0.05s here. So 0.1, 0.2, 3, 0.35. So I think this is minus 0.35. It'll be interesting to see how accurate I am here with my answer, and whether I get in the particular range that they're looking for here. So my answer here is minus 0.35. Okay, oh, just squeeze in, look at that. So I drew the line in with my best skills on the computer, and I got it between minus 0.45 to minus 0.35. So my answer is valid, and I get all 3 marks for showing that there. The tricky part here is looking at this cubic and going, okay, this is not a cubic I have. How is it similar to the cubic I've already drawn? Can I use the difference in some way to actually plot it and then find some intersection points? And you can see this is an AA star question because it's taking that knowledge you already have and then just twisting it slightly as well. So bag A contains 5 black balls and 2 white balls. Bag B contains 4 black balls and 5 white balls, as in the diagram. Gustav, I always like their names, picks one ball at random from bag A and replaces it. So that's very, very important when we're looking at these kind of questions. Write down the probability that the ball Gustav picks is black. Well, if we look at bag A, we've got 1, 2, 3, 4, 5 black balls, and there are 1, 2, 3, 4, 5, 6, 7 balls in total. So we get our answer of 5/7, like so. And Sharia picks one ball at random from bag A, notes its colour, and places it in bag B. Interesting. And then picks a ball at random from bag B. So I think this is a two-part question. Both balls are white and then one of each, I think. Yeah, exactly. So if I was to do a question like this, I would certainly draw a tree diagram. It will make your life a lot easier for just working out the answers that we need. So we're going to put in black and white, BW. You could also use B and B dash if you so wish. And we're just going to draw a quick tree diagram. It doesn't have to be the neatest thing in the world, but you do need to have that there. So let's go through. Picks a black ball. Well, we've already done that part, so that's 5/7. And probabilities always have to add up to 1, so this needs then to be 2/7. Helps if I can add 5 plus 2 is 7. There we are. I'm kind of thinking ahead to the next part of the question. So, the probability of a black ball from bag A, 5/7, and the probability of a white ball is 2/7. Now he takes that black ball, or she takes that black ball at this point, and puts it in bag B. So imagine we're going along this branch here, and I put an extra black ball. I should probably do that in black. Make it a little bit easier. So I put a black ball into bag B, and now we take a ball out at random from bag B. So notice now we've actually got 1, 2, 3, 4, 5 black balls out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 5 tenths for black, and again these always have to add up to 1. So then we get 5 tenths there, like so. Okay, and then at this point, what we do is we imagine we go back to the beginning. So I'm going back to the beginning of my situation. Now I put in a white ball. So I indicate that by a circle like this. And we go through the same logical process. So we count how many black balls. We now got 1, 2, 3, 4. So we've got 4. How many in total? We've got 10 like before. Notice these fractions will always have the same denominator, and this will then be equal to 6/10. Once you've got your diagram, it makes your life a lot easier to work out the next two parts of the question. So the probability that both balls are white, we're going to work out probability of white, is we just multiply these two fractions together. Multiply along the branches. So we get 2/7 multiplied by 6/10, which gives us 12/70. Now I've said in previous videos that I don't really mind if you don't simplify. The same thing here, but I am going to simplify this down to 6/35. Although strictly speaking this is not necessary, but try and get into good habits. So this is going to be 6/35. Notice for the next question, one ball is black and the other ball is white. I've done a lot of the hard work here. Okay? And it doesn't matter what order this is in as far as I can tell. So one ball is black and the other ball is white. So we're looking for the probability of white-black and the probability of black-white, and then we take each probability and add them together. So let's work this out. Probability of white-black, well, it's going to be going along this route. So we've got 4/10 times 2/7, should do it the other way around really. Put this in brackets. White black, and then we do black white, so we get 5/7 times 5/10. Again, I'm not going to reach my calculator, but you could at this point. We times fractions here. 4 times 2 is 8. 10 times 7 is 70. 5 times 5 is 25. 7 times 10 is 70. Notice we've got the same denominator. That's very, very helpful. If we add those together, 25 plus 8 is 33/70, which cannot be simplified. So we will leave this as 33/70. All good. Draw your tree diagrams. Okay, so now we're going on beyond the standard questions, and now they'll try and change the context slightly for this. So the balls are returned to their original bag. So if I go back to my original diagram, I would do this in the exam to remind me. I would wipe out anything I've done so far. Okay. Gene picks a ball at random from bag A. He then replaces the ball. Let's underline that. He continues to do so until he gets a white ball. Find the probability that the first time he gets a white ball is on the 5th pick. So basically what's going to happen here is you're going to pick 4 black in a row, yeah? Before then you get to pick the white ball on the 5th pick. Okay, so we need to work out that probability. So, and then we get white afterwards, of course. So we're going to go through this one at a time. Does replace the ball, so that's important. So we've got 5 over 7. Then he tries to pick another black ball, so this is our second time. The probability hasn't changed because the ball goes back. This is our third time. This is our 4th time. And now on the 5th go, we'll now choose a white ball. Notice no balls have been removed from the bag, so we've now got 2 out of 7. So we have a very, very long fraction to work out, which I am going to do on my calculator. Okay, we're not doing this, we're doing this. Okay, so let me get my GDC out. So control, divide for the fraction, 5 over 7 times, this is going to take patience, so control, 5 over 7. And the key thing here is just not to make a mistake. 5 over 7. We've now got to our 4th try. 5 over 7. Weird question, I haven't seen a question like this on iGCSE. And then 2 over 7. We get some horrible big fraction. There we are. 1,250 over 16,807. Again, 2-mark question. So I'd write that working I've just written and then write the answer. So 1,250 over 16,807. Okay, key thing is just I would write your logic here. So 4 black in a row and then a white. Okay, because otherwise the white's already picked. The balls are returned to their original bags. Leanne picks a ball at random from bag B. She continues to do this without replacement until she gets a white ball. The probability that she picks the first white ball in her nth attempt is this fraction here, 5 over 126. Find the value of n. I think I would do this by a trial and error procedure. Now notice we've got without replacement, so we need to be a bit careful. So we need to work out the black ball. So if we go back, the probability of getting a black ball here is 4 out of 9. Okay, now obviously that's not 5 over 26. So then we get times. Now we've chosen a black ball at this point, so we're going to choose another black ball. So that's going to be 3 over 8. Now what I would do is actually check this. So this is equal to 12 over 72. Which I think we can see is not the same as this fraction. This is far too big. Yeah, so this is too big. I think I take this in a trial and error, and then I would just keep going. So 4 ninths times 3 eighths times 2 sevenths. Multiply those together, we get 24 over, okay, 9 times 8 times 7. That gives you 504. Now, is that the same fraction? I think on site you can see this. You can also write this as 1 over 21. And I think we can see here these are not the same. So that's fine. But now we want to work out, okay, then we take this and then times it by the white ball. So say we've got 3 black in a row, we would then need to
times by the probability of getting a white ball at this point. So at this point, we've then got 6 balls in the bag, and 1, 2, 3, 4, 5 of them are white. So if we do 1/21 times 5, 6, that does give us the fraction that we want, 5 over 126. So the way this works is it'll be 3 black balls, then there's 1 white ball. So it'll be the 4th attempt, so n is equal to 4, where this actually occurs. Now you could check this after 2, so you could do 4 over 9 times 3 over 8 times then 5 over 7, because there are 5 white balls and 7 balls in total. If you work this out, you get 60 over 504, and we can pretty straightforwardly see this is not the same as 5 over 126. So it can't be n is equal to 3. So I've just done this by a trial and error method, and then that gives us the answer of n equals 4. I think that's probably the most straightforward way to go about this. Okay, quick look at the mark scheme so you can have a look through. Just make sure you understand the OE, which is or equivalent. I think, if I remember rightly, this is you can't just write down the number 4, you have to show corresponding working to that as well. This question was generally well answered by students, so you can see the majority were okay. The thing with part D is there's no standard method. All you need to do there is make sure you're happy with a trial and error method, and then you get to the right answer. So it's not as if you need to learn anything off by heart in order to answer that question. We have
Okay, so in a sale, a shop reduces all prices by 12%. Dina buys a book which has an original price, so this is a clue here, of $6.50. Calculate how much Dina pays for the book. So if we're reducing by 12%, well, if we've got 100% and we minus 12%, then we have then 88%. As a decimal by dividing by 100, that gives us 0.88. So to work out the new price Dina pays for the book, we do 6.50 times 0.88. So we pop that into our calculator, and that's going to give us $5.72. Okay, so this question you're seeing here is very, very typical. You've got a normal calculation, you have original price to sale price, and now this part 2 for Elu pays $11 for a toy. Calculate the original price. We're then going to be working backwards. So if we've reduced all prices by 12%, the new price, this $11, that's going to be equal to 88% of the original. But we want to find the original price. That's the clue in the question here. So we want to find 100%. And you've seen this process before, working backwards in time. So we want to then divide by 88 on both sides. That will then give us 1. And then what do we do to 1 to 100? We get to 100. So setting it out like this means you won't make a mistake going through this kind of question. So let's pop this into the calculator. Okay, so we have 11 divided by 88 times by 100. Again, we're getting a whole number answer here, which is always a very good sign. So we get 12.5, so $12.50. So we pop that in. Again, a very standard 4-mark question here, where 1, you're working out the end price, and then 1, the original price. Okay, and on to some typical investment questions. So Ferry here invests some money, and the rate of interest for the first year is 2.5%. And at the end of the second year, the overall percentage increase of Ferry's investment is actually at 6.6%. We want to work out the rate of interest that achieved that 6.6%. So the first thing that comes to mind here is we want to increase this by 2.5% in the first year. Well, if we're increasing by 2.5%, that's 102.5% in total. So if you divide by 100, it gives us 1.025. So in order to work out the overall percentage increase, the first one would be in the first year is 1.025 times some x. So x is the initial amount of money that I've started with. And then for the second year, I've got this amount, so 1.025x. And then I'm going to increase it again by another interest rate. We're going to call that R. And if I add those together, so the total from the first year and the total from the second year, that's going to be equal to an increase of 6.6%, which is going to be 100% plus 6.6%, which is 106.6%. And that gives me 1.066. So 1.066x, so of the original amount of money. Now notice we've got an x in everything here, which is very useful, so we can cancel through. That gives me then just an equation to solve here, which is 1.025 plus 1.025r is equal to 1.066. And now we just approach this like an equation. So it is an equation. So all we do is we minus 1.025 from both sides. This cancels, leaving us 1.025r. And if we take one away from the other, we get 0.041. But we want to work out this specific rate of interest. So we do the opposite of timesing by 1.025, which is dividing by 1.025 on both sides. This cancels, giving us R is equal to 0.041 over 1.025, which if we pop it into the calculator, we're going to get our interest rate of 0.04, which as a percentage is going to be equal to 4%. So the way to approach this question is, for anything that you don't know, just put a variable, in this case x, and then by constructing the situation read from the question, this problem-solving technique, then you can find a method that works for you, which then gets through to the right answer of 4%. And part D, which is often on the 0580 paper specifically, is this idea of exponential decay. Okay, this works essentially in the same way as depreciation or compound interest, but going downwards instead of upwards. So a radioactive substance decays at an exponential rate of 2% per day. The initial mass is 80 grams. Find the mass at the end of 5 days. So all we need to do here is take the initial mass, the 80. Now, if we're reducing by 2%, then that's going to be 100% minus 2%, which is equal to 98%. And add a decimal is 0.98. You see this technique again and again. So we've got 0.98. And because we've got exponential decay, then we raise it to the number of days that's happening. So to the power of 5. So we're just going to pop this into our calculator, and you'll see exactly where you can find this button to raise it to the power of 5. So we get 80 times, get the brackets out here, 0.98. And the button we're looking for is this chevron key here. So we click on this and it allows us to put any power that we want. We want to work with 5 in this case, giving us our answer then of 72.31. And generally we round this to 1 decimal place, so we're going to get 72.3 grams. And a nice little follow-up question to this is find how many more whole days after day 5 it takes for the mass to reduce to less than 67 grams. Now you could do this using logarithms, but on the 0580 course it's not on there, and 0607 it is being taken off. So the best approach then really is to do it by trial and error. So what we do, we have our equation, and all we need to do is try out different numbers until we get close. So after day 5, it's 72.31 and we want less than 67 grams. So let's just try 8. Again, we want a number bigger than 5, and we can try that out in the calculator. So 0.98 to the power of 8. Excuse me, that gives me 68.06. So that's still too high. So the next one to try would be 80 times 0.98 to the power of 9. This trial and error approach works for quite a few questions. Again, not the most efficient, but it will work. So we get 66.699 ... This is just fine. So this is lower than 67 grams. Again, we want it in whole days here. So we started at day 5, at the end of day 5, and we've got 9. So we just do 9 minus 5. So it happens after day 9, but we want how many more whole days? So 9 minus 5 is just equal to 4 days, like so. This trial and error approach, again, it might take a little bit of time getting your calculator set up, but you will get to the right answer at the end. So you can check all the answers. Again, another big old paper 4 question. So we've got 7, 9, 11 marks for this particular question. Okay, and on to question 7. And we've got some information here in a frequency table, and a very, very key topic on both iGCSE courses. This is a 0580 question, is the estimate of the mean mass. And this is a great opportunity for you to get 4 marks, because it's always the same process. Now, what we're going to do here, and you've seen this previously, is we're going to make 2 extra columns. So I'm going to make 2 extra rows, underneath. And we're going to do it exactly the same way we did before. So our first row, if we go across, again, let's line this up so it's as neat as I can make it here, is we're going to work out what's called the midpoint of the category. So we want to find halfway between 0 and 10, that's going to be 5. Halfway between 10 and 20, that's going to be 15. Now be careful on the next one. So 20 to 25, that's 22.5. And now we've got between 25 and 40. If you don't spot this straight away, one way you can do to work this out is just do 40 plus 25 divided by 2. Well, that's going to give me 65 divided by 2. And then if we work that out, that's going to give us 32.5. Again, all of that you can do in your calculator as well. And then we've got between 40 and 50 is 45. And on 0580 questions, they will change that class width. So be careful for that. Now we're going to do the midpoint. So mid times the frequency. So we're going to times these together. Now some of these you can do quite easily. So 12 times 5 is equal to 60, like so. Let's use the calculator and work the rest out. Okay, so I've done all the calculations here. So what we're going to do is pop those over. So we've got 570 and 720. So let's pop those in. So 570 and 720. And the key thing with this process is just making sure that we're careful putting these numbers in. So 1,625 and 810. So 1,625 and 810. Now at this stage we need to work out the total here. So we need the total of all these numbers. Let's go back to the calculator and work that out. Okay, so let's just pop this in. So plus 720 plus 1,625 plus 810. That gives us 3,785. So that's going to be our total here. And then to work out this estimate, remember it's an estimate because we are using the midpoint of each category. We take that 3,785 and divide it by the total. Now the total is usually given in the question, so we're given 150. So that's going to be our last step. Let's work it out. So again, you can always use the control answer, works on most calculators here. We divide by 150, giving us, well, certainly a fraction, but then we can just change this to a decimal. Just give me one moment. Again, we get that. Control enter, and there we are. We get our final answer of 25.2. Generally with these, they do want you to do it to one decimal place. ... There we are. And so to one decimal place, this is 25.2. We're going to see this again, so this is a really, really important topic. Do get in the practice from this video because it comes up a lot on the 0580 paper. Right, now we need to draw a histogram. So this is 0580 only, so you will not get histograms if you are doing 0607. And essentially what we're going to do here is a so-called frequency density diagram. Now, in order to work out the frequency density, we've seen this formula before. This is equal to the frequency divided by the class width. So what we're going to do here is make another row here. I've left this on purpose for this question because it fits in quite nicely, like so. I'm going to call this FD for short, so frequency density. And all we're going to do is we're going to find the frequency, so the 12 here, and divide it by the width. So the width of this, so between 0 and 10, well, that's just going to be equal to 10, and 12 divided by 10, that's equal to 1.2. Likewise, if we do 38, again, the width here is also 10, so 38 divided by 10, that's equal to 3.8. Next one, well, 32. This time we've got 5 here. So be careful, the width does change. If you do 32 divided by 5, that's going to be equal to 6.4. And again, you do a similar process here. Notice I'm just putting the widths in. 50 divided by 15, that's equal to 3.3 recurring. Again, you can check this on your calculator. And then the last one, of course, is just going to be 1.8. 18 divided by 10. So this gives us the height of the bars. Remember, it's a histogram, so the bars go next to each other here because we're working with continuous data. So all we do is go over to the other side, and we're going to go between 0 and 10 because that's the width here, and we want to go up to 1.2. So go between 0 and 10. Now always look at the scale carefully here. Notice we're going up in 1.2s. 1.2, 1.4, 1.6, 1.82. So we need to draw a bar across here and downwards between 0 and 10. This one's 10 and 20, so go to between 10 and 20 up to 3.8. That's going to be here. So again, the bars are continuous, so they will be next to each other. We're going here between 10 and 20, so like so. This is where the width changes, so you have to be really careful here, between 20 and 25, and we want to go up to 6.4. So notice we want 25 here. The scale here go up in ones, so 21, 22, 23, 24, 25. We want to go up as far as 6.4. Now, the best thing to do here is not get dizzy when you're doing this. And then we want a bar that goes up like so to 6.4, across, and then downwards like so. Again, obviously in the exam, please use a ruler. That will make it as accurate as possible. Then we've got between 25 and 40, which is 3.3 recurring. So I'm going to go as far as 40 here. Now 3.3 recurring, this is 3.2, this is 3.4. It's going to be halfway in between. Don't worry if you don't get it completely accurate, but just do the best that you can to make the best histogram possible. You do get a whacking 4 marks for this, so it's worth spending the time over. And then the last part of the question, 40 to 50 at 1.8. Well, 1.8 is going to be here, and then we go straight across to 50 and downwards. Please don't spend time in the exam shading those in. That is all you need to do, of course, with a ruler to get all 4 marks. Over to the next question, which is a cumulative frequency table. And the way I like to call this is a so-called running total. So I'm going to show you what I mean by that. We also have to check the class widths to make sure they correspond to the table. So what do I mean by this? Well, we start with 12 first of all, so that doesn't change. And then we're doing this running total. So we keep adding these numbers on. What do I mean by this? Well, 12 plus 38 is equal to 50. So the next one will be equal to 50. Then we've got our 50. We add on 32 to it. That gives us 82. So we just keep adding these results on. Then we've got 82 plus 50. That's equal to 132. And then the last one, 132 plus 18 is 150. And a really good double check to do here is this number should be equal to the total frequency. If we go back, the total frequency is 150, so we've got a good chance of this being the right answer. Last part of this question, so a bit of interpretation here. Find a percentage of children with a mass greater than 10 kilos. Well, notice we've only got 12 people here less than 10 kilos. So we need to do 150 minus 12. If we do that, we get 138. And we want to work out the percentage the 138 is of the total frequency. So then we divide this by 150 and then times by 100, the standard formula for working out a percentage. So let's go to the calculator and work it out. So all we do is just type in 138. Again, you can use the fraction button if you so wish. Yeah, let's use the fraction button. So here we are, 138. Make sure you definitely type it in the right place. That is very important. And then we go 150. That's it, times by 100. And that gives us 92 exactly. So we just pop over 92, and that's going to be 92%. No rounding involved in this question. So you can have a look through the answers. You can look at the widths and the heights of the frequency density graph, the histogram as well. Again, this comes from a typical 0580 paper 4 question, so make sure you are getting all these marks.